Hi guys out there, hope you're ready today to work on maths. Okay, my name is Rakubu. Today guys, we'll be focusing on the central tendency in statistics. Okay, remember when you do your mathematics, you don't just observe, you need a pen and paper to try some of the problem. That's how actually you do your mathematics. Okay, we don't read, okay, we do problems. Okay, but I'll be going through some of the concept with you today. Okay, so let's look at what we have for today. So into the measure of central tendency. Before we do that, I have a question for you. Why was the second wave of COVID-19 declared, and based on what? The second wave, what do I mean when I say second wave? Okay, when the COVID started, and we reached a peak. The peak implies the maximum, where we're recording about 13,000 daily infection per day on average, okay? And we started with like 23 cases. Then we moved to 13,000. Then that 13,000 cases went into 9,000, then started decreasing into 1,000. Decreases to 500. Then the first wave of the COVID-19 was complete in a way. We're actually on level 3 lockdown. Then the second wave was declared. Based on what? Using data. Why was the second wave declared? Because the daily infection of the COVID-19 was into 8,000. So the moving average, the average on 7 days was more of 8,000, 9,000. Hence the second wave was declared. Do you think the second wave will be higher than the first wave? What does that mean? Does it mean, are we going to get more than 13,000 COVID-19 in the second wave? Will we have the third wave? Is that possible? Can we really predict that using data or by looking at data? Okay, so that's the importance of data. It's an interesting question. I hope you thought about it and you're aware about this. Fantastic. So there's another question for you. Do you accept any claim or argument without data? If someone comes, say, there's an argument, do you accept it without data? I think we should question things. If we have data in front of us, it's better to accept an argument because someone will be presenting some evidence, okay, that this is what is happening. There's evidence that we are in second wave. Hence, probably more restrictions, if we believe that. Okay, fantastic. So I wouldn't accept with anything without data. Now, we're going to look at what do you call estimated mean of the data. After that, we'll look at something called the quartiles. Okay. Then we'll look at mean. After mean, we'll look at the median. Median, we'll look at the mode. Okay. So let's look at some of the keywords. What is central tendency? Okay. Central tendency, I mean, it's a random variable, okay, which tends towards mean, median, and mode. Mean is the average. Median, if you arrange data from the smallest to the highest, the middle one is the median. And mode is the most occurring. Okay? So I want you to go and think during the pandemic, how many people, go and find the mode, how many people got affected by COVID-19? You might find the mode. People under the age of 2, elderly, people between 30 and 40. If people between 30 and 40 are the highest with COVID-19, that will be the modal class. Okay, you can find that for yourself. So what about the extreme value? So the extreme value can either be the minimum or the maximum. Those are the extreme. We do notice extreme value in a way, okay? And when we notice extreme value, we act on that, okay? With respect to the COVID-19, there's been some extreme values in some provinces. When they do the test, they say, okay, this province, they're getting more positive case, then hence more restrictions. Those were extreme values. So the extreme value can be the highest or the minimum. But if you look at the COVID, if you want to stay on the cautious side, you look at the highest value where you have more positive cases and more restriction we impose in other provinces. So it's important that we know extreme values if we have data set, the lowest and the highest. Okay, fantastic. So now we're going to some of the keywords, frequency table and tallies. Okay, frequency table is if we can group data using age from 0 to 19, and the tallies will be how many, if we count how many people between 0 and 19, and the frequency will be the total in that category. Okay, does that make sense? Okay, so the frequency will be the total tally for that set of an interval. Okay, so the tallies and frequency, they go in hand to hand together. Now, we have estimated mean, quartiles, mean, median, mode. We're going to look at mean. Okay, so let's look at this, the mean. So the mean is what is commonly known to tend to think as the average. The mean or the average of the data is the sum of the data divided by the total number value of the data. Does that make sense? So that's the mean. Okay. So another way you can think of the mean, if you, let's say how many people affected with COVID in South Africa. I mean, if you look at the average, it can be based on tests, how many tests were conducted and how many people with positive cases. That's another way you can look at that. Okay. So in mathematics, if I put in formula, the mean will be the sum of all x value of all the observed variable over the total values of x. So this is called sigma. That science means sum, adding all the x's, and is over the total, the observation, how many values you have. Okay, let's look at an example. 2 dice were thrown 10 times, and their scores were added together and recorded. Find the mean and the range for this data. Okay, so we rolled a die, we rolled 2 dice, so we get 7. So the first die could have been 6, and the second die could have been 1, which is 7. And the second observation is 5. That could have been 1. 4 and 1, or 3 and 2. We don't know, okay? But we have the data with us. Then the second observation is 2, then 7, 6, 12, 10, 4, 8, 9, which is our 10th observation. How do we calculate the mean? We have to add everything divided. We have to add all this divided by how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see how we do this. So we have to add 7, 5, 2, 7 again, 6, 12, 10, 4, 8, 7, over 10, because we roll the 2 dice 10 times. Okay? Then what do we get? Let's see what we get. We get 70 over 10, then the average is 10. Okay. What does an average mean? Okay. Let's say you go to your maths class and you calculate the average for a maths class, and the average is 50%. What does 50% mean? Does it mean everyone in the class get 50%? Not necessary. Okay? You could have someone with 90. Okay? You could have someone with 10, 20, and so on. Okay? Just the combination of everyone divided by 10, you're getting 50%. Okay? Now, what is the range? So the range is actually the maximum minus the minimum value. So what is the maximum value here? So the maximum value is 9. The maximum value, is 12. So this would be 12. And what is the minimum? The minimum is the smallest, which is 2, which is 10. So this is the maximum minus the minimum value, which is the range. What does the range tell us? Think about this. What does the range tell us? So the highest minus the lowest. Okay? So usually a smaller range, if you compare two sets of data, will mean kind of consistency. And a bigger range, smaller consistency. Okay? Because the highest value minus the smaller, there's a gap between the two. Okay? So in South Africa, we'll look at, in terms of inequality in this country, if we calculate the highest, the person who earned the most, and the lowest, there's a huge deviation. There's a gap between the person who earns the minimum and the person who earns the highest in our country, okay, which causes lots of inequalities based on data. Okay, so data is very important. Okay, guys, so bye for now. See you after the break, and we'll continue with more statistics, data handling, and look at the central tendency. Beautiful. Welcome back once again, guys. Hope you're ready. We're going to push together. And remember, mathematics is about consistency. It's not about waking up today and doing 2 problems and tomorrow you're not doing anything. It's about consistent hard work throughout. It's better to do 30 minutes a day than doing 5 hours on Saturday. What matters the most is consistency. That's how you're going to do it. If you have that fundamental, nothing will be impossible if you go ahead with consistency. Now, let's get to the business of looking at the measure of central tendency, statistics, okay? So, what are we going to look at now? We're still going to look at quartiles. We looked at mean already, which is the average. We're going to look at median. We're going to look at mode. Now we're going to look at the estimated mean. What does estimate mean? You know, it's the estimated mean, it's not the actual mean, but close to the actual answer. That's the estimated mean. Okay. And why we use estimated mean? Because sometimes we don't have the actual raw data. We can have data in grouped. We can actually estimate a mean for that grouped data. Let's look what this estimated mean look like to us, okay, and how we interpret that. So, estimated mean of grouped data. An estimated mean can be obtained by assuming that each of the raw data value takes the midpoint value of the interval in which it has been placed. The midpoint means halfway. Are we together? Midpoints means halfway. Interval could be how many, let's look at, I'll go back to COVID, the pandemic. The interval, we can, let's say people aged between 80 and 90, that's an interval. The midpoint between 80 and 90 is 80 plus 90 divided by 2, which is halfway, which is actually 85. Okay, so we're going to look at interval and midpoint. Because we might not have the actual data. We might have a table with intervals and frequencies. And how do we calculate the mean? So to do the mean, we'll do the sum of all frequencies times the midpoint. I'll explain, it'll actually make more sense if we do the actual problem. So this is the frequency, okay, times the midpoint. This is the total number of frequency, okay? Then mathematics, this is in words. That's the meaning of that, the mean. So this means, this is sigma, it just means sum of frequency. This x is the midpoint of an interval, and this is the frequency. And that means sigma means total. Okay. Let's see with an actual table how we can do this. During a 3-hour at an airport, 55 aircraft arrived late. So we know that 55 aircraft arrived late. That's what we know. So the total frequency for this will be 55, because we're working with what? 55 planes that arrived late. The number of minutes they were taken is shown in the grouped frequency table below. So what we know is that planes that arrived late by 0 to 10 minutes, there were 27 of them. So 27 aircraft arrived by 0 to 10 minutes late. 10 by between 10 and 20 minutes late. And 7 by 10 to 20 minutes late. 5 by 30 to 40 minutes. 4 by 50 to 40 minutes late. And 2 by 50 to 60 minutes late. I mean, 50 to 60 minutes implies you're going to wait for an hour. That's too late, actually. I mean, even 40 to 50 minutes late is just too much for an aircraft. Okay. Now, we don't have raw data. We don't know plane 1 by how many minutes was late, another plane by how many minutes late. We just have a table. How do we calculate the mean? So this is not going to be the actual mean. It's going to be the estimated mean. Okay, the average of being late. Okay, good. So we calculate the midpoint. How do we calculate the midpoint? The midpoint for this will be 0 plus 10 divided by 2. That will give us 5. This is the midpoint there. Okay, can you see guys there? Which is 5. Then the midpoint for there will be 5 plus 10 divided by 2. Okay, which is, we get 15. That's the midpoint. And the midpoint for 30 and 20 is 20 plus 30, which is 50 divided by 2. We get 25. And what about 30 plus 40 divided by 2? We get 35. And 40 plus 50 divided by 2, we get 45. And 50 plus 60 divided by 2, we get 55. What does this mean? Okay, this is the average, okay? Because remember, we have 27 flights, which is the frequency, that arrived by 0 to 10 minutes late. So what it means, there is a flight, an aircraft, which is late by 1 minute, maybe by 2 minutes, by 3 minutes. But this means 27. They're just between 0 and 10 minutes. Okay, Now the average in that interval is 5 minutes. What does it mean? If an aircraft fall in that interval, the average of that flight being late is about 5 minutes. Okay, which is not bad to wait for 5 minutes. Okay, so let's look at the last one, which is between 50 and 55. 50 and 60. 50 and 60. There could be an aircraft which is late by 51 minutes, by 52 minutes, by 55 minutes. The average is 55 minutes is in that interval. I mean, you have to wait in that interval. I mean, it's 55 minutes. The max can be an hour, but the average is 55 minutes. Then from there, we have our midpoint. Now, we have to do midpoint multiplied by frequency. So what do? 5 times 2. 27 times 5. So 27 times 5, we get 135. That's the midpoint times frequency. 10 times 15, we get 150. 7 times 25, which we get 175. Then 5 times 35, 5 times 35, we get 175. And 4 times 45, 4 times 45, we get 180. And 5 times 2 is 110. Now we have midpoint multiplied by frequency. What are we going to do now is to add the sum of midpoint multiplied by frequency divided by the total frequency. And we know that the total frequency is 55 because 55 aircraft arrived late. Okay, so let's see what we get. So if we add all this, you can check that using a calculator. This is what I get. I get 925. Are we together? Divided by 55, which is the total frequency, okay, which is 16.8 minutes. 16.8 minutes. What does it mean? On average, if an aircraft is late, you have to wait for about 16 minutes and 8 seconds. Okay, does that make sense? Does it mean you'll wait that? It could be longer, could be shorter. Make sense? Which is possible. Okay. So this mean mathematical, if I have to do it, another symbol for mean is X bar. It will be sigma. Remember, this is the sum of MP times F, which is what we added, the sum of that, over the sum of frequency. This means sum. That also means sum. We call that sigma. It's a sigma. Okay. Good. Hope this makes sense, guys. Okay. Not the actual mean, but an estimated mean. Okay. Now, we've looked at the estimated mean. We still look at quartiles. We looked at the actual mean. We looked at the estimated mean. And think about what is different between the two. Which one will you take, the estimated mean or the actual mean of raw data? We'll look at the median. We'll look at the mode. Now we're going to focus on the mode. What do you think is the mode? Any idea? Have you heard of the term mode? The mode is the most occurring. Okay. What is the mode cell phone? The one you use at school, at your home. Think about it. Look at around. Okay? You'll find there is a mode. The most occurring one. Everyone that uses it. Okay. So, the mode in the data value that occurs most frequent. If two numbers that tie the frequent occurs, then the data set has two mode is called bimodal. So if you have two sets of data, I have 5, 5, 1, 3. 5 is the mode because 5 is most occurring because I have 5, 5 and 1, 2. 5 and 5 are occurring the most. 5 is the mode. But what if I have 2, 2, 3, 3, 1? 2 and 3, they tie. So I have two modes. We'll call that bimodal. It's having two modes. Okay, great. Can you think of two things that tie together? Okay, it's possible. Then you can have the two mode. Okay. So let's look at this set of data. We have 48, 49, and so on. So what is the mode here? So I have 50 there. Can you see 50? Okay, the mode is 50. 50 occur more often than any other number. So 50 is the mode. We together because it occur often, more than any other. Okay, fantastic. But what is interesting, let's go back to our, what if I don't have raw data like this? This is raw data because the data is not grouped. I can see the actual 48, 49, 52, 50, 51, and so on. I can tell that 50 is occurring more often than the other, hence is the mode. What about the table with the aircraft? I don't know. How do I tell the mode? If you go back, look at this. I want you to look at this. Now, here. Can we tell what is the mode here? What we know is that between 0 and 10 minutes, 27 aircraft were late. We don't know that aircraft 1, what time the first aircraft arrived, the second one, all the way, all the 55 aircraft. We don't have the actual numbers for the 55 aircraft. What we have is the frequency. Are we together? So the frequency, if you look at 0 to 10, that's the highest. So this, we'll call it a modal class. So it will be called modal class. Okay. What I'd like you to do is to go back to the COVID-19 pandemic. Look at which age is more affected by the COVID-19. Which class, which is the age class with the most positive cases? Go think about it. And I want you to go back also look at which class actually we lost because of the COVID-19. I want you to take time. We do know that the elderly, so you might find that between the age of 70, 80, 90, you have lots of people we lost because that's probably the mode. We don't know. But I want you to go and look at that data if possible. Okay. So actually this modal class is not really bad because implies most flight, they are late by 0 to 10 minutes. Most occurring. You know, I can wait for 10 minutes. But if the mode was there, that a flight will be late by 60 minutes, no. I wouldn't invest in that business or that aircraft. So we can use data to really analyze what is happening. I mean, you can analyze each and every aircraft if they arrive on time. Do you really want to invest in that business? Do you really want to book that aircraft? Because every aircraft in that company might be late by 50 to 60 minutes. Not a good idea. Okay, guys, so we looked at the mode, and when we come back after break, we'll look at another measure of central tendency. Okay, here I was trying to show you when we have a table, how do we really get the mode? We don't get the actual mode, we get the modal class. Okay, fantastic. Hope to see you after the break. Welcome back once again. Hope you're ready. Okay, so we're going with the measure of central tendency statistics, data analytics. There's so many careers in statistics. I mean, I think this is the world of data. Okay, it's a world of statistics. A company that understands people using data, they're able to minimize risk. There's some insurance company that actually study how you drive. They put a device in your car, they collect data on how you turn, your speed, and actually derive an insurance premium on that. Or some claim give you cash back based on how you drive, because they try to understand human by using data. Okay? Maybe they're calculating your average speed per week, or monthly, or daily, we don't know. Have a conversation with people around you. How do they drive? Okay? What is their average speed per weekly or daily? Okay? Now, let's come back. We looked at the estimated mean. We're still going to look at quartiles. We looked at mean, which is the average, and the two are the same, but just group data, and this is from raw data. We're going to look at median. We looked at mode. Now we'll look at median. Have you heard the term called median? What does median mean to you? Mean, median, is it the same thing? The median is actually if you take your data from the smallest to the highest. The middle number is the median. What does it mean? If I have marks and I arrange the marks in a class from the lowest mark to the highest, and the middle is 60, oh, what is the meaning of that? It implies because the middle 60, after 60, everyone got more than 60. Can be good. Depends on what you want to achieve. What are you looking data? Okay. But I think a median in terms of marks of 60, that's really excellent. But we don't know. Maybe that half after the median are doing well and the lower are not doing well. But we don't want that, maybe. We want something consistent. Okay. Good. So how do we look at the median? So the median is the middle value of set of data once it has been ordered. Ordered meaning you order your data from the smallest to the highest, from the lowest to the highest, minimum to maximum. You don't just pick any middle number and we call that the median. That's not the median. I want you to think out there. What if the median is the same as the mean? What does that mean to you? Think about that while you're there. So, let's look at an example. Sipho hit 11 balls at a driving range. So Sipho is actually playing what? Golf. The recorded distance of his drive measured in meters are given below. So those are the distance. I mean, 85, 125, 130, 65, 100, all the way. Okay. Now, we want to calculate the median. We have to order our data from the smallest to the highest. Let's order that. We order data from the smallest to the highest. Now, if we order our data, what is the middle one? So from there to there, and from there to there. Can we see? The middle is 85, because we've arranged our data. The smallest one is 50 there. This is our data. And the highest is 140. I see 140 there. Okay? So then the middle from we have 12, 11 data sets. So it implies I need 5 this side, and I need 5 this side. and the middle one is 85, which is the median. So the median distance is 85, which is the middle dot. Now, what we're going to look at is, what if the middle is between the two numbers? How do we find the median? Because here we have 11 numbers. It's easy because 5 that side, 5 that side. In the middle, we have one number in the middle. We can point it, which is 85. What if we have 10? Where do I find middle? Because I put 5 that side, 5 that side. What is in the middle? Oh, nothing. What if I have 8 data set? What is the middle? 4, 4. What is the middle? Let's look at that. How do we find the median? So if Sipona hits 12 ball at a driving range, the recorded distance on his drives are measured in meters, are given below. Find the median distance for his drives. So firstly, we've ordered our data. This is the actual raw data. We arrange it from the smallest to the highest. So the smallest is 50 and the highest is 150. Now, where is the median? The middle is between 85 and 95. It's between 85 and 95 because you have 10 set of data. Okay. Another way to look at this is using this formula to find the position of the median. So we can find the position of the median by saying a half n plus 1. So this is the position of the median. What is n? N is what? 12. Okay, are we together? So this is a half. 12 plus 1, which is 13 over 2. So let's look at it. 1, 2, 3, 4, 5, 6. So 13 over 2 should give us 6.5. Okay. So 6.5 means position 6.5 is the position of the median. Then we count 6.5. So this is 1, 2, 3, 4, 5, 6. 6.5 is between there. Are we together? The two middle value taken the mean. So we're going to take the mean of the two value to find the median. If we do that, we get 90. How did we do this? It's 85 plus 95 divided by 2, which give us the median. Are we all together, guys? Okay. Which is the middle value if you arrange our data from the smallest to the highest value. Fantastic. Hope this makes sense. Okay. And you're enjoying this. Now we looked at estimated mean. We're going to look at quartiles. We looked at mean, and we looked at median. We looked at mode. Now we're going to look at quartiles. What are quartiles? Have you heard of quartiles before? Okay. Have you used quartiles? Let's look at what are quartiles. So quartiles are measure of dispersion around the mean, which is better measure of central tendency. Remember, central tendency clustered around the mean. What is clustered around the mean? Mean, median, and mode. Okay. So quartiles are a measure of dispersion. Dispersion is what? It's kind of your range. The highest minus the smallest one. That's the spread of the data. Okay. Think about if the highest minus the smallest, you get a bigger number. And plus, there's a huge gap between the lowest value and the highest value. That's the dispersion. So the median divides the data into two halves. The quartile further subdivides the data into quarters. What it means, if we have a set of data from there to there, this is the median. It divides the data into a half, and a half. The quartiles, it further divides the data into quarters, so it divides that into another half there and another half there, another half this side and another half that side. Okay, so it actually divides into quarters. Okay, let's look how it does that. So quartiles, we're going to look at a lower quartile. The lower quartile will be denoted by Q1. Is the median of the lower half of the data. So what it means is, if I have data set from the smallest to the highest, the middle is the median. The lower quartile is the median from the smallest to the median. Is the mean from the smallest to the middle. Is the median of half of the data set. In simple terms. That's the lower quartile. Then the median, we already done that. This is the value that divides the data into halves. The upper quartile, which is Q3, is the median of the upper half value of the data. What it means? If the middle is the median, from there to there, the middle is the median. From the lowest to the median, I have lower quartile. Then from median, from half to the last value, that half, I'm getting the upper quartile, which is denoted by Q3, and this is Q1. Are we all together? Does that make sense? So another way we can look at this is that if I do my data, so we're going to have Q2 there, which is our median. We're going to have our Q1 there. We're going to have our Q3 there. So from there to there, you have 25% of data. And from there to there, you have 25% of the data. And from there to there, it's 25. Then another 25% of data, which is our quarters. Okay, let's see how do we actually find the quartiles using a raw data. Find the median and the quartiles for data below. Let's look at the data. So we have 12, 6, 4, 9, 8, 4, 9, 8, 5, 9, 8, and 10. So firstly, what we need to do is to arrange our data from the smallest to the highest value. Are we together? We have to arrange from the smallest to the highest value for us to calculate our quartiles. Let's order the data. Order from the smallest to the highest. So if we arrange our data from the smallest to the highest, we get 4. We have 4 4s. Let's see. I'm just going to verify. There's 4 and 4 there. We've arranged our data from the smallest to the highest. How many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12. So the best is to find the median first. Let's find the median. So the median is between 8 and 8, that position. Can you see that? So the median is there. So it's 8 plus 8 divided by 2, which gives us 8. Another way to find the position of the median is a half n plus 1. What is n? The total data set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 plus 1, which is 13 over 2, which is 6.5. Position 6.5 is the median. 1, 2, 3, 4, 5, 6. 6.5 is there. How do we find that? 8 plus 8 divided by 2, we get 8. That's the median. How do we find the lower quartile? The lower quartile, what are we going to do is to find the median of half of the data. What are we going to do is we're going to find the median, which is there. So the lower quartile is half. What is half? From there to there. Find the median. You can find the median. If you have a small set of data, you can arrange your data and look at it and find the median. But if you want the position of the median, you can use this. Because it's quarter of the data. Quarter, n plus 1, which is 1 over 4. What is n? N is 12 plus 1. 12 plus 1 is 13. 13 over 4, which is 3.5. Position 3.5 will find the median. So what are you going to go? 1, 2, 3. 3.5 is there. So which is 5 plus 6, which is 11, divided by 2, which is the lower quartile is 5.5. Now let's look at the upper quartile. The upper quartile, by looking, which is Q3, we get 9. You can do it if you have a small set of data by just arranging it and doing the data. But if I want the position, you can use 3 over 4, n plus 1, it will find the position of that. So we have our quartiles. I hope guys you enjoyed today, and we had a fantastic lesson on central tendency with me. And we hope to see you soon. And remember to keep working hard, and consistency must be one of your fundamentals. You'd rather be consistent every day if you want to be successful. It's not about working for 4 hours on weekend, one day. It's 20 minutes per day, every day makes a huge difference. Hope to see you soon, and bye.